Okay, as we discussed number 20, there is a concept that I believe is tested on 3 different problems on the actual test. So that is a straight up hint. Okay? On the actual test, the concept we are about to discuss gets tested 3 different times in 3 different ways. So that means that there isn't a problem on the test that looks like this, but there is 3 different problems that use the same concept. So you make sure that you talk about this until it's clear to you. It's not a new concept, it's just we need to talk a little bit more about it until it becomes firmly understood. In the pink packet, number 20 uses this concept. The same concept is tested on number 23. And the same concept is tested on number 26. And the same concept is tested on number 32. So 32, 26, 23, and 20 all use the same concept. I don't recall if there's ones prior to that that do or not. But another thing that will help you tremendously in this class with this whole idea of learning conceptually instead of learning problems is identifying when problems are using the same concept, like even though they look like different problems. Here it says G is a twice differentiable function. So heads up. Are they talking about G? Are they talking about G prime? Are they talking about G double prime? Heads up. G is a twice differentiable function. Which are they talking about, Preston? Everybody knew it? Point 2 for Preston. Okay, so they're talking about G. They're just saying G has G prime and G double prime. They give us 2 clues right here. These are common clues. Please raise your hand and tell me. Oops, wrong button. When you see those clues, hands up, what should you immediately do? And what should be your immediate thought? You're reading an AP test question, you see those 2 things, what should you do right away? Without hesitation or delay. Let's go, Michaela.
So it's just increasing and it's concave up.
So just say that one more time.
So
avoid the foul
G
language.
is increasing and has concave up.
So G is increasing because G prime was positive. G double prime being positive tells me that G is concave up. You knew it before she said it? Point 2 for Michaela. Anybody else? So keep reading slowly. G of 4 is 12. G of 5 is 18. When they give you values like that, it's smart to either try and draw a picture or draw a table. Either way, just don't leave them like that. It's difficult for your brain to kind of think about it in this form. You'll think about it a lot better as a table or a graph. I'm going to use a graph. I don't draw grids hardly ever in this class. I think they typically get in the way of solving the problem. Because what happens to me is I get so stuck thinking, how big is the grid supposed to be and how many tick marks? And I just don't do that anymore. I just look at that and go, hey, this looks like a perfect estimate to me, 4, 12. That's exactly where that belongs. 5, 18, that looks perfect. Okay, which of the following is possible for 6? So 6 is over here, and they ask, can 6 be 15? That would be down here. Say yes or no.
No.
And somebody raise your hand and tell me why. Go.
Because it's increasing and it's concave up, so it can't go down.
So please don't swear, but do it again.
G prime and G double prime both are increasing.
Oh, don't say that. That's not true.
I don't know anymore.
You're good. 2 points to Nate.
Just replace it. It's G is concave up and increasing, so it can't be.
You're doing just great. 3 points for Nathan. Hey, mark them down. Somebody just say it again. Matt.
G is increasing and concave up, so the points have to be increasing by a greater value. Well, the y coordinates.
That's really good. Listen to what he said.
The y coordinates need to increase by a greater amount every time.
Well said. Because G is increasing, we know that the y coordinates have to go up. Because G is concave up, those y values must go up by more and more each time. So from here to here is an increase or a change in y of 6. The change in x is 1. Therefore, the next point must go up and have a change in y that is greater than 6. So now the change in y is 9. The change in x is still 1. Okay, question. Okay, here's something you need to add to your thoughts. If this makes sense to you, hold on to this. It's a really good explanation, but add something to it that you need in other problems, okay? This little computation has a name. You must remember, has 2 names. You must remember, actually it has 3 names. You must remember all 3. One name, anybody know it? For our class, we always want to say secant slope. So that's one. We know another name? Parker?
Derivative?
2 points, but no, it's okay.
Yeah.
Derivative is always at 1 point instead of like between 2 points.
Okay.
No worries. So one name of this is secant slope between these 2 points. That's secant slope.
Rate of change.
Yeah, perfect. And just throw in the word average. So average rate of change, secant slope. Let's see, there was a third one. Shoot, maybe there's only 2.
Is it like the average velocity or the average
If this were a position graph, it would be.
average rate? Oh,
Depends. No, you're right. No, you're not. You're doing great. If this were a position graph, we wouldn't be calculating the average velocity. That's a good answer. It wasn't what I remembered, but you're doing better than me. Okay, so secant slope, average rate of change. You good? Okay. Make sure you remember those. Look, that's how they make different questions. They test you on the same idea, they just throw in different words. Is that pretty good? There's nothing you must have memorized and understood. I should say the other way. You understand first, then you memorize. Actually, it's a 3-step process. You understand first, and you create a flashcard, then it becomes memorized. So, when you look at a concave up curve, listen close. Listen close to this one. Make sense of it. When you make a concave up curve, as you observe the curve from left to right, you must be certain that as you go from slope to slope to slope, meaning you're looking at tangent slopes or secant slopes or both, as you read left to right, those slopes have to have an increasing pattern. Okay, so if the function is concave up, and you are reading the graph from left to right, and you're checking slopes, you're checking a tangent slope, and then a secant, and then a tangent, or whatever, the pattern must be increasing. Parker, please.
So I don't even know if this will ever show up on the AP test, but what if it's just a straight line that's increasing and it's just a straight slope? Or I guess how would they word that if they would at all?
Like linear? Or?
Yeah, linear. Yeah.
Your question is right on. If the function is linear, the function has no concavity. Because, in fact, I want other people to answer this, so hold on a second, Frank. It's a really good question. I got to get a picture here. Okay, I want to keep where I'm at for a second, but don't forget your question. So, here's what we have. We have a curve that is concave up. Okay? Points for the whole room. Look, please raise your hand if you can tell me. What is the slope of that pink line? Hands, come on. What's the slope of the pink line? What is the slope of the pink line there? 6 over 1. How many knew it? Point 2 for Nick. What is the slope? Yeah, no units on this one, so hands up. Those are good lines. Very proud of my lines. So. Hands up. What is the slope of the green line? Think with me, Nicole. So this one's 9. This one's 6. How many knew it? Come on. Point 2 for Nicole. Okay, here's the concept you must, 1 second. Here's the, you're doing great. I just have to finish my thought. Here's the concept you must understand, flashcard, and memorize. As you read this graph from left to right, the slope values have to increase. They are. This secant is 6, the next secant is 9. Question for the whole room. What can be said about the slope of this curve right here? So this is a tangent slope now. Tangent slope is what Parker said earlier. There's a point. Tangent slope is the derivative. Tangent slope is the instantaneous rate of change. So right here, this purple line has a slope. That's really bad. I'm so proud of my line. That's decent. Just look at the picture. Look at the picture. Raise your hand if you can tell me. Which is steeper, green or purple? Just raise your hand. Come on. Which is steeper, green or purple? Which is more positive, green or purple? Let's go, Josh. Green. Josh says the green is more positive than the purple. How many agree? Point 2 for Josh. Which is steeper, purple or pink? Come on. Which is more steep, purple or pink? Let's go, Natalie.
Purple.
The purple is more steep than the pink. How many see it? Point. That's the concept. As you read the graph from left to right, because the graph is concave up, I'm checking this secant is 6. This next tangent has to be more than 6. Back to Hannah's question, we have no way of measuring it yet, so we don't worry about that. Just, sorry. It's more than 6. But it's got to be less than 9. Go ahead, Ada, please.
So it's concave up if that graph, say, is concave up on the left, and concave up is that way, the graph still has to be increasing.
Yep. Yep. So if the graph has this kind of a shape, meaning the graph is concave down, decreasing but concave up, you will see the same pattern. What will be different is this first slope will be quite negative. As you follow the curve, it becomes less negative. Therefore, the slope is still increasing.
Because the line is getting closer to 0, getting closer to decreasing positively.
Go ahead.
That's decreasing still, right?
So this is a picture of, this is G over here. So really good to
That's G.
compliments to the whole room. Look, I hope this has been helpful to you. The questions you're asking are what you must know for the test. You don't have to do you don't have to know how to do the problems. You know the concepts. You can do any problem. Okay? This is G. This is G being increasing and concave up. And as I read the slopes, they must increase in value. This would be a G being decreasing and concave up, but as I read the slopes, they still must increase in value. You know, back to Parker's question. Everybody answer this one. For a linear line, linear function, as you read the graph from left to right, this is a trick question. If you know the trick, then you understand. Are the slopes of this graph increasing or are they decreasing? Hands up. As you read the graph from left to right, you check slope after slope after slope. Are the slopes, Bryce, increasing or decreasing? They're all the same. How many knew it? Point! Kind of exciting. Look. Answer this. Is a linear function, therefore, you did so well. This is what this class is about. It's like making sense of things. It is not about copying me. That is a waste of time in today's society. Computers are way too good. Like, you gotta learn how to think. Look, is this curve concave up or concave down? Trick question, hands up, come on. Concave up or concave down? Jane? I'm gonna say neither. point. Did that answer your question?
Yes, but I was just wondering also how they would word that question. If there was going to be a question on the AP test, how would they word something that has no concavity?
They'd have to say linear.
They'd have to say linear, so
Yeah, I've
that'd
never-
be pretty obvious.
Yeah, I don't think it would be hidden.
Okay.
I've never seen them use the word, doesn't have any concavity. I could see them describing a linear function and expecting you to recognize that it doesn't have any concavity. Did that
Okay.
answer your question?
It does.
Okay. We're a bit out of time. We have 1 minute. Okay? That's how this class is as well. If you really get into the concept, it flies by. That's why, hey, just so you know, look, I don't know, I feel like if you know my background, you understand me better. I did not leave that job because it was not interesting. That's how my job was for 13 years. Like, show up at 8 o'clock, get working, oh my gosh, it's lunch. Like, that's the kind of job you want. The other kind of job is not the kind you want. Sorry, I'm kind of excited. Anyway.